Greetings. In our last lesson, we talked about one-way ANOVA. One-way ANOVA is usually used to compare more than two means. If in the ANOVA test you reject the null hypothesis, the conclusion is that some of the means are significantly different. However, it only tells you that there are differences among the group means overall, but does not tell you which specific groups are different from each other. This is where post-hoc tests come into play. A post-hoc test is a type of statistical test that you run after finding a significant result in an ANOVA test. It helps you figure out exactly where the differences lie. You can think of the post-hoc procedures as a series of t-tests, but mathematically, the type 1 error rate is controlled at the alpha level you specify. Recall that a one-way ANOVA is needed because running multiple t-tests to compare means would severely elevate the risk of making type 1 errors. Thus, in post-hoc tests, adjustments are made to control the type 1 error rate for pairwise comparisons. There are a number of different post-hoc tests, and they share the same principle. They compare pairs of group means to determine whether they are significantly different while controlling for the type 1 error rate. In this video, I'm going to introduce a variety of post-hoc tests, including the Tukey HSD test, the Student-Newman-Code SNK test, the Tukey-Kramer test, the Games-Howell test, and the Scheffe test. The primary differences between these procedures lie in what value each test uses for the standard error. Because the choice of standard error makes some tests more conservative, such as the Scheffe test, while others are comparatively more powerful. When choosing a post-hoc test, you need to take into consideration whether you have equal group sizes, whether the assumption of equalative variances is met, and what level of tolerance you have for making type 1 errors. If the group sizes are the same, meaning that each group has the same number of observations, either the Tukey HSD or the SNK test can be used for post-hoc pairwise comparisons. The difference between the two is that Tukey HSD maintains the type 1 error rate at the chosen alpha level. That's why it's also called the honestly significant differences test. Whereas the SNK test has a greater chance of identifying significant differences, but at the cost of a higher type 1 error rate, often going beyond the alpha level you specified. When the group sizes are different, the Tukey-Kramer test is used for post-hoc comparisons. The Tukey-Kramer test is a special case of the Tukey HSD. In SPSS, you do not see an option provided under the name Tukey-Kramer because SPSS automatically adjusts for unequal group sizes by creating a harmonic sample size. The Games-Howell test is used in rare cases when the assumption of equality of variances is violated. Finally, if you ever need to make a comparison that involves more than two group means, the Scheffe method provides the flexibility to conduct complex contrasts. I demonstrated in another video how to run the Tukey HSD test in SPSS. So in this video, I'm going to demonstrate the other types of tests. The SNK test is a different version of the Tukey test. It's used when the groups in your dataset have equal sizes and equal variances. It also uses the Q statistic, but unlike the Tukey test, in which all pairwise comparisons are based on the same critical Q value, the critical Q value in the SNK test varies depending on how close the group means are when they are ranked in order. Using the car model example, on this slide, you can see that the group means are sorted. Means that are further apart in ranks are compared using higher critical Q values. In other words, Q critical values depends on the distance k between the two means being compared. If the means are next to each other in the ranked list, k equals 2. If there are m other means ranked in between, then k equals 2 plus m. In this example, when k equals 2, the critical Q value is 3.08. When k equals 3, the critical Q value is 3.77. The Q critical value is adjusted, which makes it more likely to reach statistical significance. Note that this increased statistical power comes at the cost of a greater risk of making type 1 errors. The Tukey-Kramer test is a modified version of the Tukey test for when the groups have different sizes. For pairwise comparisons, the Tukey-Kramer test still uses the Q statistic, but a formula is applied to create a harmonic n based on the different group sizes. Once the harmonic n is used, everything else is the same as in the Tukey test. The game's Howell test is used for pairwise comparisons when the assumption of homogeneity variance is not met. The game's Howell test is based on Welch's correction to the degrees freedom of the t-test. This test performs better than the Tukey HSD if variances are very unequal or moderately unequal in combination with small sample sizes. It can also be used if the sample size per group is very small. However, this test is not used often because ANOVA itself is not appropriate if the homogeneity variance assumption is violated. In SPSS, all the pairwise test options can be found in the same place. On the screen is a modified version of the car model data, in which I added one case to group 1 and 2 additional cases to group 3. When you run the one-way ANOVA, click on the post hoc button. For demonstration purpose only, I will choose SNK, Tukey, and Games Howell simultaneously. You can see in the output window that the Tukey test results indicated all three pairs had significant mean differences at the alpha equals 0.05 level. The Games Howell test, however, did not find a significant difference between the means of group 2 and group 3, with a p-value of 0.053, which is greater than 0.05. The table at the bottom is the output of the SNK test. Means without significant differences should be presented in the same column. Since the three means are in separate columns, all means are significantly different. Pay attention to the statement about the harmonic n at the bottom. This indicates that a Tukey-Kramer test was run for comparison of groups of unequal sizes, even though I picked Tukey test to begin with. Also remember that means that are not significantly different are called homogeneous subset. The last kind of post hoc test is for more complex types of comparisons. All the tests we have talked about so far are for pairwise comparisons. Assume that a researcher, based on some test information, suspects that Model 1 is different from Models 2 and 3 combined in the average number of repairs. This type of test involves more than two means and is called a complex contrast. If the test is expressed in an equation, it would be mu1 equals the average of mu2 and mu3. To test this hypothesis, we need to assign a coefficient to each mean, and all coefficients must add up to 0. The coefficients for this example can be -1, 1/2, and 1/2, or alternatively, -2, 1, and 1. Enter the coefficients into SPSS in the order of the group numbers. You click the complex contrast button, then enter -2 for group 1, 1 for group 2, and 1 for group 3. In the output, check the coefficients to make sure that they are correct, and read the p-value to see whether the null hypothesis should be rejected. You can run more than one contrast by assigning different coefficients to the means. But it is important to remember that such contrasts need to be theoretically supported, and Bonferroni adjustments to the alpha value is needed if multiple contrasts are tested. If you're interested in knowing more about this procedure, let me know and I'd be happy to show you more details.